Now this is very obvious, but it is given in the form of a question, that using properties of sets show that these equalities, right? We already know that, let us say there is set A and there is set B. So what is this area? This is A intersection B, right? So let us say for the first statement, if I take union of A with its intersection with B, right? A union A intersection B. So if I take set A union A intersection B, what do I get? I'll obviously get set A back, right? So first statement can be very well shown. What about second statement? A intersection A union B. So what will be the intersection of A with A union B? So obviously this set, entire set, will be my result. So that is A again, right? Otherwise, how do we show that two sets are equal? We show that A is subset of B and B is subset of A. Then that means that A is equal to B, and there is double implication. If A is equal to B, then these two are also true. Now using properties of sets show that the first statement. So if I take an element X that belongs to A union A intersection B, what does that mean? Now there is this element X that belongs to A union something, right? A union A intersection B. Now what does that mean? That means that X belongs to A, or X belongs to A intersection B, right? This is the meaning of this union, right? This or has come from this union. Okay, now see, if X belongs to this and X belongs to A, then we can say that A union A intersection B is subset of A. And in the second scenario where X belongs to A intersection B, when X belongs to this common area A intersection B, it definitely belongs to this set A. So this implies that X belongs to A, which again tells me this statement. So I started with this and I reached at two scenarios. Both the scenarios led me to one conclusion, that this is subset of A, right? Now I need to show the other way around. So let us consider there is an element Y which belongs to set A. Okay, I am not writing everything here for you to write exactly like that. So you can write it in your own language. I hope you have come here to understand these questions and not to copy. So if Y belongs to set A, I have started with this now. So if Y belongs to set A, then Y will definitely belong to A union with some other set, right? Now the other set can be A intersection B also. So Y, if Y belongs to A, then Y belongs to A union A intersection B. That means A is subset of A union A intersection B, right? I hope these two conditions are sufficient to show that A, this statement written on left hand side, is equal to this set A, right? So if I can show these two things, I can show the required statement that is to be shown. Now some people may not understand this step which I have written directly here, because Y belongs to A, then Y belongs to A union with some other set, right? So if it belongs to A, right, then it will belong to A's union with some other set. So I have taken that some other set as A intersection B, which was given in the question. If some of you want to take it as something else, let us say I write this process once again. If Y belongs to A, right, that would imply Y belongs to A union B, right? If Y belongs to some set A, then Y will definitely belong to A union B, right? Now you see y belongs to A, y belongs to A union B. That means y will belong to A intersection A union B, right? Now apply the distributive property. That will mean y belongs to A intersection A union A intersection B, right? Which means y belongs to, this is A intersection A is A union A intersection B, which is something that I took here directly. Okay, and what about this second part? Second part is almost, or you can say exactly on the same lines. So I expect you to solve this second part yourself. All right, let's look at what do we have next. Show that A intersection B is equal to A intersection C need not imply B is equal to C. So what I'm going to do is I'll take sets A, B and C in such a way that it will not imply B equal to C. So that is enough for me to show this, right? So let us say set A is equal to 1, 2. Let us take 3 also. Set B is equal to 2, 3, 4. And set C, see A intersection B on the left hand side will give me 2, 3. So it should be equal to A intersection C. So whatever C I will have, it should have 2, 3 in it. And the third element, let us say, is 5. And let us take one more element, 6. So from here itself, you can see this condition is satisfied because you can say A intersection B is equal to 2, 3. And what is A intersection C? A intersection C is also 2, 3. Right? I have taken the sets meeting these two conditions. Now, does it imply B equal to C? No. B and C are entirely different because C has got 4 elements in it. B has got only 3 elements. So for two sets to be equal, they should have exactly the same elements, which is not true in this case. So I have shown that it does not, hence B is not equal to C here, right? So it does not imply that B equal to C. It doesn't mean that it is never true, right? For something to be true, it should be always true. So you just have to show only one exception, which I have shown here, right? That means this much exercise is enough to show the required condition. Okay. A intersection X is equal to B intersection X, and it is given equal to phi. A union X is equal to B union X. So A union X is equal to B union X. It is given. We need to show A equal to B. Okay. So if A union X is equal to B union X, can I say A intersection A union X is equal to A intersection B union X? Right? Because this was the given statement. Based on it, I have said this. Right? Now I'll distribute this intersection over this union. So A intersection A union A intersection X is equal to A intersection B union A intersection X. All right. A intersection B union A intersection X. Okay. So what is A intersection A? It is A. And union, what is A intersection X? It is phi. And it is equal to A intersection B. A intersection B union A intersection X, which is phi. Right? So if I take union of a set, non-empty set, with an empty set, it will give me A. Right? This union will give me A. and this union of course will give me A intersection B. And now see, if A is equal to A intersection B, imagine this condition, right? This intersection is the entire A, or let me show it to you in other way. Let us say this is A, right? This set is A intersection B, and it is entire A also, right? So what does that mean? This A has to be subset of B. If A is equal to A intersection B, right? This is common area between A and B. So I can say that this A will definitely be subset of B, right? This means this. You can imagine this, or you can visualize this using the pictorial representation. Okay, so A is subset of B. Now if I can show that B is subset of A, then it will be enough for me to say that A is equal to B. To show that B is subset of A, let me use this once again, this relation, right? Let me make some space on the right hand side so that I can show you parallelly. Okay, so let me start once again with this expression A union X is equal to B union X. Now this time let me write B intersection A union X equals B intersection B union X, right? And as you can notice, I can distribute this intersection over union. So B intersection A union B intersection X will be equal to B intersection B union B intersection X. As we know, B intersection X is phi, right? So this is phi, this is phi. This will give me B intersection A union phi is equal to B intersection B, which is B itself, union phi. So union of a set with an empty set is the set itself. So B intersection A is equal to set B. And again, if B intersection A is equal to B, then that means this set B is subset of set A, right? Or in other way around, B is equal to B intersection A, right? Imagine in your mind, if there is B which is inside A, right? So its intersection with A will be B itself. So B is definitely a subset of A. And if these two conditions are simultaneously true, that A is subset of B and B is subset of A, then that means A and B are the same set, right? So A is equal to B. Or you mathematically you can write, if A is subset of B and B is subset of A, then that means A is equal to B. Okay. So let's continue to the next question. Find sets A, B and C such that A intersection B, B intersection C, A intersection C are non-empty sets, and A intersection B intersection C is phi, that is empty set. So this question wants us to find certain sets. So let me assume a set A having elements 1 and 2, set B having elements 2, 3. You cannot assume set B to be 3, 4. You have to have some common element, right? Why? Because these are non-empty sets. So there has to be some element. So you have to consider A and B in a way that there is some common element. Similarly, I need to consider C in such a way that set B and set C are having something in common. So let me assume this as 3 and 1. Why did I take 1 here? Because set C and set A should also have something in common, because their intersection should be non-empty. So by considering these, like these sets, I have made sure that these three sets are non-empty sets. Now you can see that A intersection B intersection C, what is common in all three? 1 here, so 1 is not here, 2 is here, 2 is not here. So you can notice that there is nothing common in all three of them. So I can say that it is equal to 5, and this is one of my answers, right? This is one of such sets. All right, so shall we do the next question in this lecture itself? Let us see. There are 600 students in a school. 150 students were found to be taking tea. So number of students taking tea is 150. Number of students taking coffee is 225. 100 were taking both tea and coffee. So number of taking both tea and coffee is equal to 100. Find how many students take neither tea nor coffee. So let us first of all find students who take either tea or coffee. So it will be equal to this 150 plus this 225 minus 100, right? So 50 and this is 225, 275. Okay, so these are the students who take either tea or coffee. Okay, and what is the total universe? What are the total students in this survey? 600 students. So the students who take neither tea nor coffee will be complement of this set. That means 600 minus this 275, that is 325 such students who take neither tea nor coffee. Okay, let us have a look at the next question. There is a group of students. 100 students know Hindi, so number of students knowing Hindi is 100. 50 know English. Number of students who know English is 50. 25 know both, so Hindi and English, 25. Each of the students knows either Hindi or English. That means we are talking about the entire universe. Every student knows either Hindi or English. So how many students are there in the group? So whatever their union is, number of students in the union of these two will give me the total students in the group. So it is equal to 100 plus 50 minus 25. That is 125 students. Okay, let us move to the next question. Okay, there is a survey of 60 people. It was found that 25 read newspaper H. Okay, so there are 25 who read newspaper H and 26 read newspaper T. Newspaper T is read by 26 and 26 read newspaper I. Number of readers of this I are also 26. 9 read both H and I. H and I is read by 9. 11 read both H and T. 11. 8 read both T and I. T and I is read by 8. And 3 read all the newspapers. H, T and I is read by 3 people. Okay, now we need to find number of people who read at least one of the newspapers. That means at least, when I say at least, that means I want the number who read one newspaper or two newspapers or all the three newspapers. The second question that is there is the number of people who read exactly one newspaper. Okay, so I've created some space here because it seems a little lengthy question. So let us draw this Venn diagram, and there are 3 newspapers. So let me draw 3 circles intersecting each other. because there are people who are common to all these three, right? H, then there is T, and there is I. Okay, so let me start with the inside area, which is common to all of three. So these people are three in number who read all the newspapers, and the people who read only two newspapers like T and I are eight. So if you look at this area which is common to T and I, it has got 3 here, and total I need 8. So I'll write 5 here, right? Similarly, common area of H and T has got 11 elements. So 3 are covered here. I'll write 8 here. So total common to both H and T are 11. And common to H and I should be 9. So 3 are here. So I'll write 6 here. Alright. Now number of people who read newspaper H are 25. Right. So this circle which shows the readers of newspaper H should have 25 people in it, out of which 8 plus 3 11 plus 6 17 are written already. So rest 8 I'll write here. So now if you see this circle for meant for this newspaper readers of paper H, it has got 25 people in it. Now number of people who read newspaper T are 26. So 8 plus 3 11 plus 5 16 are written already. So 10 will be here. And number of people who read newspaper I are 26. So 6 plus 3 9 plus 5 14 is written already. So out of 26 14 are these, 12 will be here. Okay, and this was a survey of 60 people, so there can be some people who read nothing, right, who read no paper out of these papers, right? So but the question I am interested in is, first question is the number of people who read at least one of the newspapers. So everything that is written inside these circles will give me the answer to my first question, because these read at least, like for example these 8 people read only this paper H, but these 8 people read H as well as T, right? And these 3 people read all the 3. So what will be my answer to first question? 8 plus 8 plus 3 plus 6 plus 10 plus 5 plus 12, everything that is written inside these circles. So 8 plus 8 16 plus 3 19 plus 6 25 plus 5 30 40 and 52. So 52 people are such who will read at least one of the newspapers. So if there was a question that how many people read nothing, no newspaper, so you will say 60 minus 52, that is there are 8 people who are outside of these circles, right, who read no newspaper. Now number of people who read exactly one newspaper, so these people, these 8, these 10 and these 12 people, they are the people who read exactly one newspaper. These 8 people read only newspaper H, these 10 people read only T, these 12 people read only I. So the answer to the second part will be 8 plus 10 plus 12, that is 30. 30 such people who read exactly one newspaper. In a survey, okay, there is little problem in formatting, so give me a moment here. Now I think it is okay. All right, give me one more moment, then we will continue. So this question looks exactly like the previous one, so let me start with the Venn diagram itself. So there are product A, product B and product C. So there are 3 products, A, B and C. Product A, B and C, and this is the universal set. Let me change the color to black. Alright, it is found that 21 people liked product A, 26 people liked product B, 29 people liked product C. What I'll start with is the common area which is common to all these three. So I'm looking for that data first. So read this question and start looking for that data. 14 people like product A and B, 12 C and A, 14 B and C, 8 like all the three products. So I'll start with 8 here. It is the number that likes all the three products. Now I'll look at the number who like two of the products. So 14 people are such who like product A and B. So the area that is common to A and B should have the number 14. So it has got 8 already. So 6 will be written here. So now the area common to A and B has got 14 people, right? So this condition is met. Now look at the next one. 12 people like product C and A. So the common area of C and A should have 12 people. So it has got 8 already. So let me write 4 here. Right? 14 people are common to B and C. So B and C have got 14 people in common. So I'll write 6 here. So 8 plus 6 is 14. Alright. So these conditions are met. Now let us look at these conditions. 21 people liked product A. Out of these 21, 6, 8 and 4 are written here. So 6 plus 4, 10 plus 8. 18 are already written out of these 21. So rest 3 will be written here. Okay. What about these 26 people who like product B? So 6 plus 6, 12 plus 8, 20 are written here. So 6 will be written here. And 29 people like product C. Out of that, 18 are written already. 6 plus 4, 10 plus 8, 18. And out of 29. So 18 are written already and 11 will come here. Now this has become 29. So all of the data I have taken care of. Now let us look. Find how many liked product C only. So answer is pretty simple. 11 people like C only. Alright, there can be some other questions based on this problem also, but the question was pretty simple. How many like product C only? So these are 11 such people. Okay, so this was about this chapter sets. I hope you would have enjoyed studying it with me. Thank you.